All right, ladies and gentlemen, today we're going to be talking about carboxylic acid and their derivatives and the kind of reactions they undergo. As a quick reminder, here's the principal difference between an aldehyde and a ketone and an acid and one of the derivatives. So the main difference here is when this is subjected to a nucleophilic attack, either through the acid or the base catalyzed pathway, you wind up with this in one form or another. This is a carbonyl addition reaction because the pi bond is gone. Now, when you react the acids and the acid derivatives to nucleophiles, what you get is generally this. All right, so this is a acyl substitution reaction. Now I'm going to redraw this down here a little further because it's kind of important to note. When we talk about the different types of acids and acid derivatives you have, they're all going to vary by this X value. And because you know in this reaction, pointing up here, you know in this reaction you're forming or you're kicking off that X group. So what we could say here, and you'd be right if you did, X is a leaving group, which means X needs to be a stable anion. And how do we tell if it's going to be a stable anion? Go all the way back to the pKa values, ladies and gentlemen. The lower the pKa of the protonated X, whatever it happens to be, means it is a good leaving group, or the better the leaving group is. All right, so now let's look at the carboxylic acid itself. So looking at the carboxylic acid, what we've got here is the OH right there. That's our X group. Now, what we're going to do now is we're going to look at all of the possible derivatives that you can. Sorry about that, folks. My computer freaked out on me there for a second. So what we're going to do now is we are going to look at all of the possible derivatives for the acid. And there are several of them. So I'm going to write these in a very specific order. It does matter. The first one we're going to talk about is up here. This is the acid chloride. This is the anhydride. Here we have the ester. Going down toward the bottom now, we've got this, which is the amide. And now at the very bottom, we have this. This is called the salt. So there are the primary functional groups that I'm going to require you to know. With that in mind, let's look at the differences here between them. One of the rules you have in all of this is that you can go from the acid to a derivative. Pick your derivative. You can go back and forth between any acid and any derivative, and this is all one step. One step can accomplish all of these. Okay, that's wonderful. You can go down this list. You can go down this list in one step. So you can go from the acid chloride to anything underneath it in one step. The acid anhydride to anything underneath it in one step. The ester down the chart in one step. What you cannot do, ever, 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 you absolutely cannot go up. So you can't go from an amide to an acid chloride in one step. What you would have to do, if you wanted to do that, would be you would have to take your, let's say you wanted to go from the amide to the acid chloride. You'd have to start here, go to there, and then go to there. So, quick reiteration before I go on to the next slide. This is the main principle behind the acids and the acid derivatives, is that they undergo, you can form them into all these useful derivatives that can do all kinds of fun chemistry. You can go down this chart, everything in one step. You can go to any of the derivatives from the acid in one step, but what you cannot do is go up. All right, so now let's look at ways of making carboxylic acids. This is how we're going to make these as we work. Now, we've already seen some of these. For example, you could take an alkyne and react it with ozone and water, and you get two acids out of it. You get two different, you get the acid out from the cleavage of the alkyne. Another way that we have to do this is, take a primary alcohol and react it with chromic acid and water, and that will get you to the carboxylic acid. Okay, there's another method that you've sort of seen before in labs, so let's talk our way through it. This is going to be, not that, I misspelled it, sorry. This is going to be the hydration of a nitrile. So, the overall reaction that we are looking at here is this. The nitrile with acid and water will put you here at the carboxylic acid. Now, if you're out there saying to yourself, this looks a lot like the Ritter reaction that we did a long time ago, you're not entirely wrong. This is very much like the Ritter reaction. It's just we're using water now instead of an alcohol. So I'm going to see if I can get this written on one screen, because I hate breaking up mechanisms over multiple screens. I feel like it loses something. So let's give it a try. Except it's not a carbon there, dummy. It's a nitrogen. All right. So the nitrile, the first thing it does is it deprotonates the hydronium, and you go to this. So now you've got the protonated nitrile. Water will come in, nucleophilically attack that carbon, break open the carbon-oxygen pi bond. You've heard all of this before. And this is what you get. And you can probably guess the next thing that happens is you pull one of the protons off of the OH2 you just added, neutralizing everything out. And now you're here. All right, so now you're here. The next phase of this is the oxygen forms a pi bond between the carbon and the oxygen, opening up opening up that carbon-nitrogen pi bond, which puts you here. Okay. Now, so we're at this point. The nitrogen can grab one more proton off of the OH, which puts you here. And then water comes in, attacks that carbon, knocks the NH3 off, and we now have this. All right, we've got this protonated oxygen here. All we need to do is pull that off with another water molecule, and lo and behold, you get that. Now, this is kind of a complicated mechanism, so I invite you to go back and rewatch this a couple times or cross-check it with your book. Either of those options is perfectly acceptable. All right? So, this is how we made carboxylic acids. There's one more I want to show you, and I'm quickly running out of time. So, let's just do this one pretty quickly. You can make a carboxylic acid by reacting a Grignard reagent with dry ice to start with, followed by water. And you will make benzoic acid. Now here's how this works. What's dry ice? What's dry ice? Oh, I forgot. You can't actually respond, can you? I was laughing at my own joke so hard, I messed up the structure. That's dry ice. It's carbon dioxide solid. Nucleophilic attack on that carbon opens up one of the carbon-oxygen pi bonds, and we're here. I'm running out of time, so I'm not going to get to finish this one out, but what I want you to realize is that you'd add acid and you get the benzoic acid out of that. Okay, that's all for right now, folks. Tomorrow, or next time we come back, we're going to discuss how we make some of these derivatives. So until then, stay safe, everybody.